Now we want to look at the level curves of this function. Those are the curves f of x, y equals c. Now I think on the document I asked for level curves that, for c equals 0, c equals 1, c equals 2, whatever. I'm just doing it in general here. You can obviously do exactly what I asked. But the curve f of xy equals c is the curve, well, f of xy being x plus square root of y. It's the curve x plus square root of y equals c. If we solve this for y, just to get the function, y is a function of x for the level curve, we get y equals quantity x minus c squared. Now, there's a little question on the algebra of this, so just quickly. If I solve this, I get c minus x equals the square root of y, and I'm going to have to square that. If I square c minus x, it's the same as if I square x minus c. Why is that? Well, because c minus x is just the negative of x minus c. You can work it out. You put the negative through, you get a negative x matches this, and a positive c, which matches this. So that c minus x quantity squared equals x minus c quantity squared. So that I can write this in the familiar order, y equals quantity x minus c squared. Now everybody should understand that the graph of y equals x minus c squared is just the graph of y equals x minus c, which is just a simple parabola with its vertex at the origin. Then to get this, we have to shift c units in the positive x direction. So that a typical graph would be y versus x with the vertex at x equals c. Then the curves for c equals 0, 1, 2, 3 would march across the x-axis like this. C equals 1 would have vertex at x equals 1. The c equals 2 curve would have vertex at x equals 2, and so forth. Now remember what these represent. These represent the curve you get if you slice whatever surface gives you this graph at this value of z. So the c equals 0 curve, you slice the graph at the xy plane, the plane where z equals 0. The c equals 1 graph means f of xy equals 1. Well, f of xy is the z coordinate, so you're slicing now at z equals 1. And then at z equals 2 and at z equals 3. And what kind of a curve does that give you? Well, if the x-axis is this way, then increasing values of c march toward the camera. Okay, y is this way, and our curves are parabolas that open in the y direction. The first one opens in the direction of the positive y-axis and has its vertex at the origin. That's what you get in the xy plane. You go up 1 unit, and now that parabola is the same except it's shifted 1 unit to the right. You go to the z equals 2 plane, and the parabola shifts a unit to the right. You go up 1 unit, the parabola shifts a unit to the right. So you got these parabolas that are kind of moving this way. Can you visualize the surface? Again, if you're visualizing it correctly, you know that when you slice it at whatever height, the vertex has moved this far from the z-axis. It's originally at the origin on the z-axis, that's this one, and then moves 1 unit to the right, 1 unit to the right, 1 unit to the right smoothly, so the parabola kind of moves upward and to the right and sweeps out the surface. Hopefully that reconciles with what you see here, but we're going to do a little bit more with it. Okay. Okay, well that's the shape of the surface. I'm starting something new here, so I'll start that in the video, in a new video.